The broadcast is now starting. All attendees are in listen-only mode.
Good day, everyone, and welcome to the DOE Fuel Cell Technologies Office monthly webinar series. In today's installment, Daryl Pollica, leader of Team SimpleFuel, will present his journey through the DOE's H-Prize competition. My name is Chris Worth, and I am the organizer for this meeting. We'll begin shortly, but first I have a few housekeeping items to tell you about. Today's webinar is being recorded, and the recording, along with the slides, will be posted to our EERE website in about 10 days. We will send out an email to attendees once those are posted to the site. Next slide, please. All attendees will be on mute throughout the webinar, so please submit your questions via the question box that you should see on your webinar panel. We will cover those questions during the Q&A at the end of the presentation. Next slide, please. With that, I would like to introduce our DOE host, Katie Randolph, joining me in the Department of Energy's Golden Field office in Golden, Colorado. Katie is a technology manager within the Fuel Cell Technologies office. It's a pleasure to have you with us here today, Katie. Good afternoon.
Thanks, Chris, and thanks for getting this webinar set up. As Chris mentioned, I'm a technology manager with the Fuel Cell Technologies office, and I had the opportunity to manage the H-Prize competition. And that's, as Chris said, our presentation today is going to be focused on our winning team's journey through the competition. So just a quick little background on the H-Prize. The DOE's H2 Refuel H-Prize competition, which is administered by the Hydrogen Education Foundation, was launched in 2014, and we were really trying to challenge America's innovators to deploy on-site hydrogen generation systems using electricity or natural gas to fuel hydrogen vehicles, and that could be used like in homes, community centers, or similar locations. It's a two-phase competition with an initial design phase followed by the demonstration phase where the finalists were asked to build and demonstrate their systems and demonstrate that they could meet the technical and cost criteria established for the competition, with the highest scoring qualifying entry winning the prize. So the criteria included things like dispensing pressure, dispensing time, number of standard fills per day, total system cost, etc. And it also had to be judged adequately safe by the safety panel. So Team SimpleFuel was selected as the finalist in January of 2015 and completed the demonstration phase last fall and was just recently announced the $1 million prize winner. So the Team SimpleFuel is a partnership among the three contributors. Team leader and product owner is Ibis Energy Solutions of Massachusetts, PDC Machines of Pennsylvania, and McPhee Energy North America of Massachusetts. Today, Daryl Pollica will be presenting on the team's journey, as Chris said, through the H-Prize competition, as well as providing some technical information on the system and their future plans. So, building on over 15 years of experience in the hydrogen fuel cell industry, Daryl founded the Massachusetts-based Ibis Energy Solutions in 2014 to develop innovative technologies and products to help enable the successful near-term rollout of fuel cell vehicles. In this regard, Daryl was the architect and team leader of SimpleFuel, which is a compact, cost-effective, and readily deployable refueling solution for home-based and fleet applications. So with that, Daryl, I'll turn it over to you.
Thank you, Katie. That was a warm welcome, and thank you, Chris, for setting up the webinar. And thank you, everyone who is attending today remotely and listening in. I hope to educate you in kind of our long pathway and journey to develop this really innovative product for the industry, and hope to keep it upbeat and lively, and we definitely welcome your questions and hope to answer those effectively at the end of the session. So with no further ado, let's describe how the H-Prize competition drove the innovation with SimpleFuel. Next slide, please. So the driver, and those who know me and may have seen me in some presentations before have seen this slide before. The whole chicken and the egg with the infrastructure of hydrogen fuel cell electric vehicles and hydrogen infrastructure, which comes first, right? And we struggle with that, all of us in the industry, on a day-to-day basis. So the driver here was really to create enabling solutions to increase fuel cell electric vehicle adoption. And the impetus, at least in our case, in our involvement here, was the H2 refuel H-Prize competition initiated by the U.S. Department of Energy to really spur and promote American innovators to team up and bring innovative solutions to the table to address this very important and timely need. Next slide. Katie did a description of the H-Prize quite well, so I try not to belabor this too much further, but there are some important points in my reflection in terms of the role of the H-Prize competition I wanted to highlight. So again, H-Prize was created as part of the Energy Independence and Security Act. It was written into, it was an act of Congress and written into that act in 2007 with the goal to advance research, development, demonstration, and commercial application of hydrogen energy technologies. And hydrogen energy technologies is being a key segment and a key strategic fuel for our energy and independence and security. This is an initiative by the Department of Energy, Energy Efficiency Renewable Energy, and the Fuel Cell Technology Office, and as Katie said, administered by the Hydrogen Education Foundation. This round, which we ended up joining in, was the 2014 to 2016 H-Prize H2 Refuel, again targeting innovative solutions for home and community-based refuelers. Now the important thing that I wanted to get across here when I look at the role of H-Prize is that, again, this is competition-based. There is no guarantee of any payout. This is not a grant, it's not a cooperative agreement as many of us are involved with Department of Energy. This is pure competition-based, and this really promotes what I see as American innovation, right? This is the spirit of what America was based on in terms of having, you know, risk takers and entrepreneurial spirit teaming together to bring compelling technologies and advancing technologies to the marketplace. So being competition-based, it certainly promoted or incentivized companies to team up, but you definitely had to have the wherewithal and definitely the willingness to jump into such a competition because, again, this was a 2-year development effort and not for the faint of heart. It takes a lot of effort to do these, and there was a lot of good teams involved in this competition. So it's a wonderful element to bring to this kind of spurring development and innovation in the U.S. The approach, also a key element for us, is a customer focus. So number one, everything starts with the customer. I have the quote over there. For those that are Patriot fans, you'll find that in the Gillette Stadium. The tenets of our SimpleFuel design approach was, in focusing on the customer, was first and foremost safety. Safety first and going beyond compliance. In addition to that, the end result of the device needed to be compact and easy to install, and it ultimately had to be cost effective. For the customer, we wanted this thing to be easy to use, friendly and approachable. You know, there's a lot of large plants and other models out there that you know, that puts a lot of equipment on site. It can be big, it can be unwielding for perhaps new customers in a nascent market such as ours. So we really wanted to stress an easy to use, friendly and approachable. Networkable, obviously this device is modular, it's deployable and distributable in multiple locations. We wanted it also to be digital in that this refueler could stand alone or it could certainly be networked and operate as a network, talking to each other and providing a resource or a fueling resource to customers looking for fuel. And again, and last but not least, is looking for ways that we can excite the customer in this design. The prize criteria, which you'll find a buku amount of information on the hydrogenprize.org website. I certainly suggest everyone to go there. There's guidelines and a lot of detail. But I highlight these here. Katie already mentioned them. You can see the weighting, a minimum score and a maximum score, and there's tiers in between. The reason why I wanted to show this is the fact that, and anyone that is developing products will agree with me, that some of the hardest or the most difficult phase of initial product development is understanding the customer needs and wants and what's exciting to them, and understand what those market criteria are so that you can then focus your design efforts. So I have to applaud the whole team, the Fuel Cell Technology Office and other teams that I'm sure collaborated on this, to come up with this scoring criteria, because it essentially did all of that heavy lifting and hard work right up front to in some way to look at this, make it easy for us product developers to focus our engineering efforts and design efforts to meet these criteria. They were very thoughtful, they were timely, and they were relevant. So you know, I applaud the team for putting such thought into the scoring criteria and the weighting. To go on to the next slide, again talking about the customer. So the H2 refuel was specifically looking at single-family homes and multifamily community or community refuelers, which you'll see at the bottom of this pyramid. And this is really a focus around this opportunity dispense, a return to base type of refueling model. Generally, they're lower capacity, and this is really lends itself to these small refueling appliances. Of course, the H2 refuel program was afforded anywhere between 1 to 50 kilograms per day. We focused our energies and effort on a 5 kilogram per day home environment, which is the bottom of the tier. But as I note kind of on the left side, the SimpleFuel appliance that we were envisioning and designing and wanted to build really could have synergies throughout much of that pyramid, where again, even if you extend to workplaces or fleets, there are this opportunity for return to base refueling where small incremental fills could make sense, especially in managed fleets. So it covers a wide breadth of the marketplace. Now, it would be remiss of me not to highlight the value of the team. For me, this is the essential ingredient for a successful rollout of any product or any initiative. I personally take immense pride in developing teams and strong, capable teams. And the SimpleFuel team that we assembled here is no different. So it was very clear, and in fact even promoted on the H2 Refuel initiative, which is to have multiple American innovators team up to create this new technology, not just one. So in fact, they were suggesting and promoting teaming. And this obviously didn't lay flat with us. This is what we do. Specifically, we wanted to make sure that we were creating a new innovative product, but we wanted proven technologies inside. This is extremely innovative because we were focusing on a refueling appliance that could go all the way up to 700 bar, and that was not done in the industry to date. So it required tremendous innovation in terms of integration of technologies, but we wanted proven technologies to go in there and proven bench strength that we could rely on. So I'm happy to acknowledge the wonderful team that we had assembled with PDC Machines and McPhee Energy North America, who brought loads of bench strength and loads of technical capability to the table. So as you see here, Ivis, myself and Chris included, sitting at the table today, over 30 years of experience in system integration and deployment, especially in fuel cell and hydrogen technologies. Our partner PDC Machines that had over 300 hydrogen compressors in fueling scenarios, so high pressure, high purity situations, so proven technology. And McPhee Energy North America that was leveraging their technology with over 3,000 electrolyzers deployed in service, and again, a very cost-effective and robust technology that we were bringing into the product. A little snapshot of each company, and not to belabor this, you can always go back to our websites or contact us directly. But IVAS's role in the hydrogen industry, both Chris and I was a founding member of Nuvera Fuel Cells. Chris came 1 or 2 years after the founding of Nuvera, but we worked together to develop many, many innovative technologies, especially focusing around product appliance. Again, integrated, cost-effective, things that you can imagine being mass-produced and placed in the home or other environments. You know, a lot of our focus in the later years was on-site generation and delivery of hydrogen that happened to be using steam reforming technology. We were involved in the first refueling station in Massachusetts. And we actually have a current award with the Department of Energy, which we're very excited about, which is to develop a state-of-the-art H70T40 dispenser. So that's ongoing work as well. We're actively involved in hydrogen codes and standards. And only to say that our development location, a pretty thriving, dynamic environment. It's the largest clean tech startup incubator in the United States, which is Greentown Labs, just outside of Boston in Somerville. And stay tuned there because we have some exciting news coming out in the coming weeks about upcoming projects that we're going to be involved with the state. To speak on behalf of PDC, Kareem and his team, over 300 compressors, as we said, representing over 60% of the world market, outstanding, vertically integrated. They have a manufacturing floor, again, deep bench strength, and that includes the worldwide global support of both parts and people. So wonderful technology there. And then McPhee Energy, North America, at a glance, you know, they're leveraging technology from their centers overseas. But North America, you know, really innovative products both on the electrolyzer technology, both at small and megawatt scale. They also have hydrogen storage technology for solid state storage of hydrogen, working really into major growth markets, which is industry, energy, and mobility. So a wonderful partner there. All right, well, the process of creating a new and innovative process, for those that have been deeply involved in that in the past, or even if you haven't, you can imagine that it starts with some chicken scratches on paper. So I am certain that that is my handwriting of my first conceptual layout, and I have, of course, chicken scratches before that, of really what I was envisioning within the heart of the SimpleFuel appliance, and how it was going to be shaped, how it was going to meet codes and standards, be inherently safe, and again, have some of these customer exciters. You know, we had a really talented industrial designer that we brought on board because, again, this thing, we wanted to have it look cool and be approachable and, again, exciting to the marketplace. We worked on numerous versions and models of this, of how we were going to architect the system, configure the subsystem so that would be manufacturable, would allow for development over time. So lots of thought went into there, and you can even see some drawings there where we're thinking about various people's access to the hardware, ADA compliancy, etc. So over time, we started to whittle further and further the vision and the packaging to what we came down at the very bottom, which is the SimpleFuel appliance with some neat lighting effects to really compel people to come to the unit. And what we created was this very new class of refueling appliance. It was a 5 kilogram a day, 700 bar capable hydrogen delivery solution. This was unheard of in the market. I believe it was the first of its kind, so extremely innovative from that standpoint. We'll talk about the size and the footprint later, but it's generally about 6.5 feet long, the base, and 3.5 feet deep. So it's very small footprint and meant to be a drop-in installation. It's inherently modular. It is scalable for evolving markets, so it can represent the final deployment, or it can in fact be a seed that could be ganged up and be used in multiple locations. as suggested by the H-Prize criteria, focusing on these opportunity dispenses where you're putting in what was deemed a standard fill was 1 kilogram. But typically between 0.5 kilogram to 1.5 kilograms, we could do more as well. We'll show some data on this. But the point was to be able to give somebody 2 to 4 days of drive time in this kind of window of 5 to 15-minute refuel time. And in doing so, obviously, we want to be cost competitive so that we can deploy and be synergistic with and equivalent to also the larger stations that's out there and the large networks that are being built up, which is exciting in its own right. Using electrolysis, it is neat because it lends itself maybe a little easier to renewable hydrogen options as the electric grid over time greens up, or you place it in certain applications where you have renewable electricity, either solar, wind, hydro, etc. And I won't belabor this, but obviously it was designed around the automotive market, but it very much can serve the need of the forklift market, which, as we know, is a wonderful case study, a success story for the fuel cell industry in terms of the first adopting, in large volume fuel cell technology in the marketplace, and this turn in that way in captive fleets and warehouses. The build. A lot of effort goes into the build. First and foremost, picking the site. It's got to go somewhere. Our partner PDC Machines, it made a lot of sense because not only were we manufacturing the prototype at their facility, they were really, really excited to adopt a fleet and want to grow a workplace fleet of fuel cell electric vehicles out of PDC Machines. It's a wonderful testimony to their love for this industry and wanting to promote it further and further. So we, obviously we're doing a lot of site reviews, layout, figuring out how to meet codes and standards and what type of modifications we would have to do for that type of location. And you can see the pictures down below. This is the unit in progress and some of the team members. I believe that's actually one of the electrical engineers, Dwayne from PDC Machines, that was helping us out and probably spent weeks with his head in the electrical panel wiring this thing up. A lot of complexity into the unit to bring all the way from generation to dispensing in a single innovative unit. And there's some of the team on the right side, Kareem on the left, Chris Basilico, a staff engineer with PDC Machines, Mohammed from McPhee, who was instrumental, and of course myself. This lends us to the shakedown. So you might be wondering, well, where's the cool imagery of the SimpleFuel kind of sweeping stylistic shape? Well, honestly, our initial shakedown of the unit was in an ISO container, and that served its purpose for just the shakedown period, so that we could get familiar with all the inner workings of the device and fine-tune it. So there you see the site being built up, kind of accommodating the location and the pad for the SimpleFueler. On the bottom left, us working with some test cylinder tanks, which I acknowledge at the end, but I want to thank Air Liquide for support there in terms of test tanks. Again, Mohammed and I working on the unit. And in the bottom right, that is the team, Emmanuel and company, and Chris Ainscoe from NREL, when we installed the data box, which provided secure data transfer from the unit to NREL for data analysis. And as part of this program, we had to install, in some cases, redundant instrumentation so that there was integrity of the data being generated by the device being sent securely to the data box and then to NREL for data analysis for the integrity of the competition. Lots of work. And then we get into the community outreach. So, you know, we really loved this, and PDC Machines, the whole company backed us up on this and did tremendous efforts in terms of community outreach. The Warwick-Bucks County is where PDC Machines is located. We had a first responder visit in late August. It was an incredible turnout, probably 50 to 60 folks, first responders coming out, fire, people from the, I believe it was 3 fire departments, lots of great questions, anywhere from the refueler to even the car. So it was really engaging, and they were excited to see it and loved being a part of kind of the journey as well. So huge support by the local community and the fire folks, first responders. It didn't stop there. You know, PDC Machines also reached out to the local schools to provide education of how this clean technology works, how the refueler works, how the fuel cell electric vehicle works, and how this is coming down the pipe, and to be, you know, these children are hopefully going to all be driving fuel cell electric vehicles as they get their licenses in the coming years and decades. So really, again, wonderful events where they could touch, feel, use, and experience this new technology, which I believe you can't start early enough to educate the young people of this country. On November 9th, we had our ribbon cutting. So we invited Sunita, Director of the Fuel Cell Technology Office, and all of her team out. It was well attended. Unfortunately, we had a cold and rainy day, but that didn't stop the enthusiasm of the whole team. Sunita said some incredibly nice words about the mission of hydrogen and fuel cell electric vehicles and how important it is to our country and our energy policy, and what a you know, and the role again of the H Prize to promote technology. Here is Sunita doing an actual opportunity fill to the to our vehicle, and this is where I want to just take a moment to thank Hyundai for providing their fuel cell electric vehicle, the Hyundai Tucson, to this whole activity. It was instrumental to get real-world experience using the refueler with a vehicle, and you know, the folks at PDC Machines and us, you know, got to drive the vehicle and really exercise the machine as a result. So a wonderful thank you to that team for bringing that to the table. And this is Nihad of PDC Machines. She, as well as Chris Basilico, Kareem, and others in their team helped to support us in doing countless fills to exercise this machine over about every aspect of the parameter space you can imagine. So wonderful effort applied there by the team. And when you boil it down, this map is dated actually in November. I think we hit a limit on terms of Google how many points we could put and map. But through the competition, we generated enough hydrogen. It was over 180 kilograms of hydrogen. If you assume a fuel cell electric car getting about, let's just say, 65 miles per kilogram, that is nearly 12,000 miles of driving distance that we refueled during the H Prize competition, which could basically drive around the perimeter of the United States and then some. So it's an exciting, interesting way to project the test results in terms of mileage driven. And that's about the standard mileage an average user would have in a year use of their car. So it's quite telling to the amount of use we got out of the machine in such a short period of 3 months. Next slide. I'm going to hand this off to Chris O'Brien for the next few slides as he talks about the next phase of the H Prize, which is the detailed validation testing that we gained and acquired through the H-Prize competition.
Hello, everyone. Happy to be here with you today. So I'm going to talk about some of the detailed data from our validation testing period. So this was a 3-month period in the fall of 2016. The way the H-Prize competition was set up was that each finalist system was going to run at least 60 days of test time during a 3-month period at the last stage of the competition. So I'm just going to say a couple of things about sort of how the testing period was set up, and then we can move on to a little bit more detail on the data. So this was really a very rigorous validation process. As Daryl just mentioned on the last slide, there were over 12,000 miles worth of fuel delivered and dispensed during this test process from our 5 kilogram a day system. Part of that was that a very key requirement of the competition was the availability of the system and the capacity utilization of the system. So over the 12 or 13 weeks of testing that happened, for each week we were required to have a planned amount of uptime, and uptime counted only if we were actually refilling cars. And the availability requirement was to be up over 80% of that planned time at an absolute minimum. And also to make sure that this isn't just a system sitting there humming away, not filling any cars, there was the requirement that we should operate at least 50% of the rated capacity for each week that is part of the test. So in our case, for our 5 kilogram a day system, our maximum capacity was 35 kilograms per week. So any week we were running, we had to deliver at least about 17.5, 18 kilograms for that week to count as part of the competition. So those are pretty strict requirements for a prototype system, and it was really quite energizing for the team to try to meet that really high bar. And I'll talk a little bit more about that on the next slide. But just a quick summary of this 3-month period. The blue area you can see there is our total hydrogen dispensed. You can see that going up over time. We dispensed about 180 kilograms over the H-Prize test period. And the green dots you see there are the end pressure of the fill. So obviously we're targeting a 700 bar capable appliance, where a good number of the fills should be to 700 bar to demonstrate that capability. And we also wanted to exercise it over the whole range, because we do think that this will be used in applications where sometimes you're doing a fill from an empty tank where you just want enough to drive away. Sometimes you're doing a top-off fill. Sometimes you're doing something in between. So we had the opportunity during this test period to really run over a very wide range of test conditions. So this is the 700 bar 5 kilogram a day system, and over the H-Prize test period, we demonstrated about 180 fills at an average of about 1 kilogram per fill. Since then, we've done quite a few more fills, and all this was either to test tanks when the vehicle didn't need enough hydrogen, we weren't able to drive it enough, or to the Hyundai vehicle. Okay, so a few statistics about all of those fills and relative to the H-Prize criteria. So these are the 180 or so fills that you saw on the previous chart, shown in a couple of the ways in these histograms here. Fill pressure, a little bit under 20% of our fills were to 700 bar, so full pressure in the tank. Actually, over 30% were over 690 bar. So a good number of them were up at that range. You can also see that we had another sort of peak in our fueling at around about 200 bar, and that's consistent with coming in pretty empty on your vehicle tank and putting a kilogram or a kilogram and a half in there, so a day or two worth of driving depending on how much you drive. So that's another area, but we did try to spread it out over all the various vehicle states of charge, so you see a lot of different fill pressures in there. In terms of the fill amount, that's the green chart over to the right on the top. The standard fill defined by the H-prize was 1 kilogram. And a lot of the metrics in terms of fill rate and that sort of thing were defined around that 1 kilogram fill. So we did do a lot of fills in that range, right about 1 kilogram of dispensed hydrogen. But we also, again, got to exercise it over a much wider range, down to relatively low fill amounts, less than half a kilogram, and up to much larger fills that would be the kind of thing that you might do in an overnight kind of situation, or where you have a need for more hydrogen in a single fill. So we went all the way up to more than 3 kilograms in a single fill. Fill rate. That's again one of the criteria, and obviously it's a big concern for everybody in the hydrogen industry. So the fill rates that we saw depended on a lot of things. They depend on the vehicle state of charge. They depend on the state of our internal buffer storage. There's a small buffer in the system that lets us manage the production and delivery balance. So there are a lot of things that go into it. And one of the great things about this test, running so many different fills and exercising the system to a high capacity, was that we really got an idea of how these fill rates would change with all the different ways that a car might come up and times that a car might come up and different states of the system. Our average fill rate was between 10 and 20 minutes per kilogram. And we'll put that in context in the next couple of slides. But with a little bit of management of the system, we could pretty easily keep that in that range of 30 minutes per kilogram or less. You'll see some very long fill rates on that chart, and again, that was because we did try to exercise the system in some sort of off-design conditions to see what, how it would perform, for example, with very low buffer storage or that kind of situation, or very large fills. So that's the fill rate. And I emphasized on the last slide the availability and capacity utilization requirements of the competition. So that last chart in the bottom corner is showing the weekly results for availability and utilization. So you can see the availability kind of varying over time, but generally quite high. We did have a period in the middle. You notice that it started in the big ISO box, and then partway through the competition, we got to put the fun container on it with our final design. So we did take the system down for a few days, and you'll see the drop in availability for that to put that enclosure on there. And then the filled lines at the bottom show that capacity requirement. So the purple one, that's given how many days we're planned to run any given week, what our maximum capacity would be, and then the green is the actual delivered capacity during that week. The orange line you see there is the ratio of those two, which was our capacity. That was required to be above 50% for every week we ran. So again, this was a great motivator to do a really strenuous test on our prototype system here, and to really move towards great validation very quickly. And I'll just thank again NREL for their support in the data collection and validation with the H-Prize. They were very, very responsive and made sure that their systems were always working. If we had a power outage or anything like that, they were immediately ready to respond and get things back in order. So great job by the NREL team there. And I just want to point out a couple of different refueling scenarios that happen. These are some of the fills that happened during the test period, and kind of bracketing the range of things that you might see with the system. The first one is an opportunity to dispense. In this case, car coming in at very low state of charge. So we're putting a relatively small mass on, 1.4 kilograms in this case, to a lower final pressure. The car is coming in relatively empty, so you're filling it only up to about 200 bar in this case. That allows for a relatively quick fill. We had a final fill rate on this of 6 minutes per kilogram. So in a little over 8.5 minutes, 1.4 kilograms got onto that car, ready to drive away, and we got more than 100 miles of range added. The bottom chart shows a full fill kind of situation. In this case, it was a little over 3 kilograms being dispensed onto the car in a single dispense. And this is much longer. It was over 2 hours. The fill rate, which is the purple line, you can see that going up over time during the fill. So basically the fill slows down as we go. You still get that first kilogram relatively quickly in about 10, 12 minutes, but then the fill rate does slow down as our internal buffer depletes. But the system can still keep going and fill that car. So our target application for this sort of fill would be a situation where maybe you want to do an overnight fill, or it's installed in a shop where they want to fill up a car before giving it back to a customer, and time is not a critical concern. So that's a totally different application. So those are some just detail fills there, and I'm going to hand it back to Daryl to put these in some context. And again, thank you to the H-Prize team for putting together a really strenuous validation that gave us good motivation to get a lot of testing done in a short time.
Thank you, Chris. That prior slide was, again, just 2 examples of refueling scenarios of actual validation data collected on the system. It gives you a little sense of some of the bookends of what the system's capability is. This plot here is somewhat of an average or typical. It is also a real data set, but is kind of indicative of what we would call as a top-off. In this case, almost 1.5 kilograms, or is 1.5 kilograms, so larger than the standard fill, topping all the way off to 700 bar pressure. And to give you a sense of what that means in this context, and what you were seeing on the prior slides, is that this fill rate of what we're giving to the vehicle, to put in context with battery electric vehicles and battery electric vehicle chargers, supplying as hydrogen, even in this compact appliance where we are doing slower fills than the typical fast fill station, we are still working in a competitive range to even that of level 3 fast chargers or better. And so, for instance, just when you look at the plot above, when you see 14 minutes per kilogram, if you assume a kilogram gives you 65 miles range on the fuel cell electric vehicle, plus or minus, that's around 4.6 to 5 miles of range added per minute. So it is right there, even in this kind of, in that fill scenario, is competitive with a level 3 fast charger. So it gives you a sense of the rangeability and the competitiveness of hydrogen and of this appliance. A key element, as we'll talk about in the next few slides, obviously is simplicity to install and ultimately cost. The installation requirements are fairly basic. Again, it's meant to be a drop-in install. You need to supply power per spec, an RO water supply, and depending if you gang these up or if you put multiple on a site, then that supply could change or vary as well, either smaller or larger unit. But it's really nothing more than what you'd find under a sink in a Lowe's or a Home Depot type equipment. Vents, there are 2 vents, and you do need vehicle impact protection bollards. You know, we had a detailed design review, both of documentation design review and then of physical prototype inspection by the U.S. Hydrogen Safety Panel members. So wonderful feedback that they provided and guidance that they provided to help that we could then use and integrate into to further our system design. And lastly, when it comes to installation requirements, the standard home install and cost was provided by some expert panel members in terms of providing guidance to what that cost would be, leveraging our actual cost that we provided on our own site. Just to say one last thing is that as we look forward to make installation even easier is going to be, we are ongoing or undergoing an appliance certification with the folk through Intertech, which will be an ETL mark. Don't want to belabor this one, but periodic inspection and maintenance, there's standard maintenance and there's actual maintenance. Every time the unit was touched, no matter what it was, we had to provide that information to the H-Prize committee and to NREL, who was tracking every bit of it, and provide fully loaded labor rates, cost of materials, etc. So all of that is baked into the direct user cost, which we'll see on the next slide. So this is a snapshot of some key performances of this prototype appliance. Now again, this is not the commercialized appliance. This is our first prototype. But we were really ecstatic with how well this worked out of the design box. As you can see, in terms of keeping availability high and be able to do all the fills that we did. The dispense pressure, as Chris showed on the plots, we did many, many dispenses up to 700 bar. The capacity here was 5 kilograms a day. And the things in parentheses are simply to say that the same design has the ability to expand up to 10 kilograms per day. So that's something that's in our product roadmap. Fueling rate, as you saw on the histograms, generally or typically between that mark of 5 to 30 is where the bulk of the experience was in terms of refueling. We had several verifications of hydrogen quality, which was absolutely paramount, and in fact some of those were data sent site unseen by or sight unseen from us, meaning the data went directly from the analytical house to the data committee of HPRIZE and NREL to ensure integrity of the data. Power consumption, RO water, you can see all that. The noise is literally if you're standing right at the face of the appliance. A few feet back, it's down into it's 60 or less. Dimensions, 6.5 feet long, roughly 3.5 feet deep. So again, very small appliance. It does have one electrical panel, which you can see in the photo above the vehicle, above the windshield of the vehicle. You can see on the wall that would be the one interface power distribution box. Getting to the cost, everyone's asking, or everyone will be interested on this prototype. Our installed system cost was less than $35K per kilogram. I want to stress to all the folks that have either done product development or have not, is that for a prototype to come out of the gate with such a tight, stringent cost target is actually quite challenging. So we're very proud of this mark, and we now have an extremely good understanding of the cost structure of the appliance, and we're going to go with the commercialized product. And important to say, the direct user cost. So this is all the fully loaded operation and maintenance. So the dollar per kilogram at the pump for the user is $15 per kilogram. So that is synergistic with what you'll find typically out there in the marketplace at the large commercial stations. And there we go. So that and among reams and reams of data sets and cost auditing, BOM reviews, performance data, et cetera, all had to be shared with the committee to evaluate the system. And we are extremely pleased to have met all the basic technical and cost criteria, and including being able to operate and perform over the 3-month performance test, meeting those requirements to ultimately become the HPRIZE winner. So we are ecstatic about that. Our future plans, of course, don't stop there. So we are actively engaged in commercialization activities. You can imagine this at residential or multifamily residences. Workplace refueling, whether it's for your employees or if you have your own workplace fleet, it gives an instant drop-in solution for you to go green. There is a big opportunity also in terms of supporting customers, again going to customer as being first. We're looking at the OEMs and the dealerships and the service centers where these vehicles are being rolled out, having an easy access to refueling right there at the service center to provide, let's say, a topped-off fuel cell electric vehicle after it's been serviced and give that perk to the customer. And last but not least, of course, the SimpleFuel can operate or could be envisioned in the future as a seed for the larger station growth at existing retail stations. So it brings a green customer or maintains the linkage to these customers who are adopting now electric vehicles to still come to the store and the convenience store. So it expands their reach. So lastly, I want to give my sincere thanks and acknowledgments on behalf of the entire SimpleFuel team, which includes IVAS, PDC, and McPhee Energy North America, to all these folks here. So of course the U.S. Department of Energy, ERE, and the Fuel Cell Technology Office, Sunita, and our whole team did an outstanding job to, one, initiate this whole H-Prize competition and see and have the foresight of the importance of this for energy independence. The creation of the H2 Refuel prize competition for the 2014-2016 round. The Hydrogen Education Foundation, which did a tremendous job administering this for the U.S. Department of Energy and keeping everyone tied in and communicated. NREL, who did a wonderful job in terms of the data box and the data integrity. The Hydrogen Safety Panel, who provided important guidance in terms of safe design of the system and critical review of our architecture. Hyundai, who I said before, I have to thank in terms of the vehicle. We would not be able to do and demonstrate what we have here, especially refueling the vehicle, without your wonderful support. And lastly, Air Liquide, who provided some test equipment, tank equipment for us to help complement our vehicle refueling. With that, I will hand it off to Chris Worth, who will guide you through the Q&A session.
So this is Katie. I'm going to be asking you the questions. First off, I'd like to thank you, Daryl and Chris. That was a very informative and interesting presentation. I was lucky enough to get to follow it day by day. So thank you for sharing your story with this broader audience. As you all know, please enter your question and answers in the question box as shown on this. And we are getting lots of questions, so I'm just going to dive right into them.
Great.
So the first is, how big are each of the three companies in market size, and how many team members were assigned to the SimpleFuel team?
So in terms of the team size, so we had 2 members and then growing to 3 members on the IVAS side. Team members at PDC Machines was at times 4. And at times maybe 8 to 10, especially as you can imagine when we're doing the building of the machine, and then ultimately the site install and testing. And then McPhee Energy North America, there was consistently 1 to 2 folks, and sometimes expanding to 3 or 4, especially when we were putting the equipment together and beginning the testing.
Okay, next question. What is the size of the buffer storage in kilograms? And is the electrolyzer, compressor, and storage all in the cabinet we're seeing?
I'll take that one. Yes, everything is enclosed in the cabinet that you see there. Daryl mentioned, I'll scroll back to this. You'll see a very small electrical box with a red switch on it up above the windshield of the car.
Oh, yeah.
And that's our safety system in there. We intentionally keep that separate from the main box for various requirements in terms of NFPA2, but everything else is inside that enclosure. And I'm not going to answer on the amount of hydrogen storage, other than to say it is similar to what you'd find in a regular, normal hydrogen fuel cell electric customer vehicle today.
Okay.
Part of Katie, just to add to that, part of our architectural approach is the concept that you can so-called park this refueler wherever you can park a fuel cell electric vehicle. That was the design intent. So the amount of onboard storage was built around that concept.
Okay, thank you. What is the average consumption of electricity for your system?
The system runs at about 15 kilowatts when it's running and generating hydrogen as in sort of an average power. So that's about what it was, and the consumption in terms of kilograms of hydrogen delivered to a vehicle at 700 bar was around about 80 kilowatt hours, 80 to 85 kilowatt hours per kilogram delivered to the vehicle at 700 bar. And that includes generation, compression, dispense, all of those things.
Okay. Did you monitor the vehicle tank temperature during the fueling test?
So we have, we do in fact have that data. That is with our partner Hyundai, and yeah, so we do have that data. I should just say that our system was designed, or this one for H-Prize was non-communication, but our commercial devices will include communication.
Okay. Sorry, they're coming in fast. My screen. Okay. The 35,000 per kilogram station cost translate to what total capital cost? What kilogram rating are you using for this station?
That was the cost for our actual prototype build, installed build. So that's for the 5 kilogram per day prototype. And one of the interesting requirements of the H-Prize competition was that this is not a cost of something that's modeled in volume production. This is actual cost as spent. We had to provide all sorts of documentation.
Invoices, purchase orders, yes, all the documentation.
For the actual prototype system. So that's for the 5 kilogram per day system.
Unit 1.
All right. If you compare your system to the level 3 chargers, how does the cost compare between the two systems?
That depends a lot on where you want to put your level 3 charger. So to maintain about the same rates that we're showing on the chart there, you need about 120 to 180 kilowatts of power supply to that charger. That's not insignificant. So a good part of the cost of that charger does go into that. Not an expert in level 3 charger installation, but it's
well, I mean, some of the information that we are aware of is that those level 3 chargers could be somewhere on the order of $250,000 and installed. So you know, it's up there in cost, similar kind of ballpark to again what one of these hydrogen refuelers ballpark would be.
So for the cost models, what is the year's expected life on the SimpleFuel appliance, and what is the average price for power used, dollars per kilowatt hour?
So the price that was used was provided by the H-Prize committee. They came up with a appropriate average, and Katie, maybe you'll remember better than me. I believe it was 9.8 cents per kilogram per kilowatt hour.
Yes, that's how I recall too.
Yep. And in terms of the life of the system, so the direct user cost, I'll just back up. That is the actual cost during the 3-month test period. So tracking the actual kilowatt hour usage of this system, water usage, and all maintenance, including parts and labor. That's how that direct user cost was calculated. It does not involve any modeling over the life of the system. We are designing this system for a 10 to 20 year life. It's first prototype, so there's a lot of testing to do before we validate that.
Yeah, we don't see any reason why there would not be a refurbishment period and extend this to 15 years plus.
Okay. And what is the water quality required for your system?
We can give very specific water quality requirements, but it's a basic RO water, so something that you'd get from sort of an under the sink RO system. It's not particularly stringent.
Yeah, and it's not DI water or deionized.
Yeah. All right, so next question. If installed for fleet or demonstration recharging, how many vehicles will the system likely support?
We have the right slide up for this one.
Yeah.
If you space out the fills in the right way and can manage your fleet, and the system does provide data, it has connectivity to do that, to help you do that, you could support 10 vehicles more or less with the 5 kilogram per day unit, up to 20 vehicles with a 10 kilogram per day variant, and up to that level of vehicles with a little bit of fleet management in terms of when you do your refueling. We can keep all the fill times to 15 minutes per kilogram or less.
Yeah, general reference at a very high level, global level, typical user, if they're driving like 12 to 13,000 miles per year, on average is about consuming around ½ kilogram a day. So that gives you a kind of a sense of the number of vehicles supported by the daily capacity.
And what were your most significant challenges when you began building and throughout the build and demonstration of the system?
How long do we have left?
Yeah, this will probably be the last question and answer.
It's a good one. It's a good one. You want to start?
Yeah, I'll throw a few in there. The schedule was tight. It was a lot to get done between about February timeframe when the finalist announcements went out to having the system up and running and testing in the early part of September. So that schedule was pretty tough to meet, but we did get there. Some of the other challenges in this were really sort of figuring out how to manage such a sort of small, compact device and still meet the needs of refilling, this number of vehicles per day. So a lot of work into managing, balancing out all the different components that are in there: electrolyzer size, compression, storage, delivery, and control systems around that, to be able to actively manage how much hydrogen we keep on board and fill the vehicle. Great learning experience for us as we went through the test period and exercised all sorts of different ways on that.
Yeah, I would just add one other way to look at this is, having been kind of in these rodeos before of developing, new technology, innovative technology, we knew very much from the very beginning that there was two important challenges for us, which was going to be to ensure the safety, from an architecture standpoint, the safety of the unit, make sure that was #1 priority, and by setting that as #1 priority, by defining that architecture from the very beginning, that actually lessened a lot of issues that we would have had if we had not done that at the very beginning. And then the other one is just simply that there would be, without the support of the other team members, PDC Machines and McPhee Energy North America, IVUS would not have been able to achieve what we did with this device. So again, what could have been an incredible uphill battle and challenge for a company like IVUS, we addressed from the very beginning, so that we teamed up with the right partners from the get-go, and that actually removed a tremendous amount of barriers that would have been there otherwise.
Well, Daryl and Chris, thank you guys so much again for this very interesting and useful presentation. The questions are continuing to come in. Can I encourage that they reach out to you through the IVUS webpage? Is that the best way to get contact information?
You will flood my inbox, but feel free to send me. The email is at the very end of the slide set. So feel free to send those, and please bear with me if it takes me a little bit to respond to everyone, but I will try my best. I'm excited that people are interested.
Yeah, I can't keep up, and unfortunately we're out of time, but I would like to thank you again, the whole SimpleFuel team, and congratulations on winning the H Prize. So I will turn it over to Chris Worth to end the webinar.
Thank you, Katie.
Hey, thanks, Katie. And again, thank you, Daryl and team, for a great presentation. And Katie, thank you for hosting a great Q&A session here as well. Again, if we didn't get to your questions, thank you, Daryl, for volunteering to take those to your inbox there, and to Katie as well. I will remind everyone that the webinar and slides will be available online at the Fuel Cell Webinars website shown in about 10 days. That's hydrogenandfuelcells.energy.gov. Also, I encourage everyone to sign up for our monthly newsletter, which includes information and registration for upcoming webinars. You can sign up for that on the website shown as well. Thanks for signing in, everyone, and listening. Have a great rest of your week. Bye-bye.